Good evening, everyone. Welcome to this Embedded System Design, IoT and PCB Design Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. Firstly, I would like to welcome the early comers first. Welcome, Victor, welcome, Amrish, welcome, Abidun, welcome, Nilani, welcome, and Lokeshwaran, welcome, Harigrasudan, welcome, Kausar, welcome, Palnivel, welcome, Aman Gupta, welcome, Anurag, welcome, Hemant, welcome. If I'm audible, just type yes in the chat box. Okay. Hemant, Anurag, welcome. Navdeep Kumar, welcome. Anurag Tiwari, welcome. Puram Kavita, welcome. Hariharan, Charandeep, welcome. Tangeshwari, welcome. And Karthik, Hari Krishna, welcome. Hemant, welcome. Nilani, welcome. Omkar, welcome. Augustine Joseph, welcome. Okay, Omkar, thanks. Mahendra, welcome. Hari Krishna, welcome. Mukesh, welcome. Jeevarajan, Navya, Ravi Kumar. Anirudh, Sivaram, Vivek, welcome. Jesh, welcome. Bharat, welcome. Okay. Devendra Shah, welcome. Charandeep, welcome. Lokeshwaran, welcome. Code Hacker, welcome. And Akash, welcome. KS Mahendra and Sanam, welcome. Rahul, welcome. Jayesh, welcome. So thank you so much. Tamil Insights, welcome. Fala Electronics, Mahenda, welcome. Narendra Varni, welcome. Nagaraj, welcome. Okay. So today we are going to learn the basic element of embedded system design and what is IDE, what is integrated development environment, what is compiler, what is linker, what is assembler, and what is loader, and the hardware design flow, and what is software design flow, and what are all the programming techniques used in embedded system design. Okay, what is in application programming, what is ISP programming, in circuit serial programming, what is JTAG, and what are the embedded peripherals, common embedded peripherals like GPIOs, like CAN, what is CAN, UART, SPI, I2C, what are the common embedded peripherals are available, and what are the test and measurement equipments which is used for embedded system design. Okay, and finally, introduction to RTOS, real-time operating system. So this is the thing which we are going to learn today. Okay, before we go to the session, like I would like to shortly recap what we have learned yesterday. Okay, can you type on the chat box what we learned yesterday? Can you type any single point is okay. Like what we have learned yesterday. Like the first slide we have caught up what is the definition of embedded system, and we have gone through the examples of embedded system design. Okay, just type in the chat box what we have learned yesterday. I would like to read out your names. Satya Singh, welcome. Rajmohan, welcome. Priya, welcome. Kaushik, welcome. Venukumar, welcome. Okay. Darkness Writer, welcome. Vani Priya, welcome. Okay. What is that? What is that? We microcontroller? Yes. Nilani is microcontroller, DSP, ASIC, and FPGA. Okay. The difference between we learned the difference between microprocessors, microcontrollers, DSPs, ASIC, and FPGA. Okay, we learn. Okay. Noel is type of CPUs. Okay. Hemant is telling type of CPUs. Okay. Hari Krishna is telling difference between microprocessor and microcontroller. Okay. Okay. And different types of microcontrollers and types. Okay. Okay. ASIC. When to use microcontroller was DSP. Asokan is telling when to use microcontroller was DSP. DSP was FPGA. Okay. SOC. We have caught up SOC. Okay. So CPLD is FPGA. Devi Prasad is telling CPLD is FPGA. Okay. Okay. Right. Choosing the right microcontroller. Okay. Choose how to choose the right processor for your embedded system design. Okay, that's what we have caught up yesterday. And today is all about the challenges of embedded system design and what are the common embedded peripherals and what are the programming techniques. Okay, that's what we are going to see today and the basics of RTOS. Okay, if this is the first time you are attending the event today, if you have not attended yesterday and this is the first time you are attending, just type FT in the chat box. First time in the chat box. FT in the chat box. You have not attended the session yesterday, but you have attended. This is the first class for today. Just type FT in the chat box. I would like to personally welcome you for this 30-day challenge. Okay. Nagarajan, okay, DigiKey, still learning about DigiKey. Hard real time and soft real time. Okay. Praveen is telling hard real time and soft real time. Okay. TA Momap, Madhu is telling TA Momap. Okay. Mauli DigiKey is a supplier. Okay. Ravi Kumar, welcome. Ravi Kumar, first time. And Victory, welcome. Anaya, welcome. FT, first time. Satish, welcome. Okay, I could see a lot of names. Yuvraj, welcome. Okay, so Can you give me permission? Can you give me permission for taking 2 minutes of your time to explain about myself? Because we are going to connect for the next 29 days. Okay. Just type P for permission to explain about me. I'll just take only 1 or 2 minutes, not more than that. I'm waiting for a chat. Okay. Okay. Arman, welcome. Nayan, welcome. I could see a lot of, okay. Hemant, thank you. I could see a lot of names. Pradap Mohan, thank you. Okay. Okay. Sabarishwaran, thank you. Nilani, thank you. Okay. So my name is N.K. Jeevarajan. Okay. I completed my master's in the year 2004 from College of Engineering, Gindi, and my bachelor degree in the year 2002 from Government College of Engineering, Bargur. And I have 19 plus years of experience in designing development boards like microcontroller boards, DSP boards, and FPGA boards. I also have knowledge on digital marketing. Okay, I used to run digital marketing for my own company. Generator like I have personally lead the team building 300 plus products, in-house design products, and generated 70 plus crores of revenue. Okay, the best product I designed in my 19 years is called BrainSense, which is a brain computer interface device, which is the first manufactured consumer grade BCI in India, tied up with a company called Neurosky, which is used to read your EEG signals and control things. You can also use for attention deficiency children's to improve their attentions. And this product has been selected as the top 5 innovation products in India in the year 2015 by NASCA. If you want to connect with me, I have my LinkedIn link in the chat box. Just send me a connection request. I'm happy to connect and happy to help. Okay, our mission is to help 10 million students to learn the technology in an easy way. For the past 2 years, we have trained more than 4 lakh plus students, and we have issued nearly around 2 lakh plus certificates for free. Okay, for free. It means who have attended more than 25 days. So I personally welcome you on this journey and love to connect with you. So let's go for the session. Okay. So if you're ready to learn, just type RTL in the chat box. Ready to learn the chat box. Okay. First, we'll start with the basic elements of embedded system design. What are the components in embedded system design? So basically, you have the input variables and the output variables. Okay, and you have the user interface for programming or to give input to the controllers, and you have link to the other systems, like you have interfaces which is used to connect this embedded system design with the other microcontrollers, other embedded systems, or other processors. Okay, so basically you have the input variables, which is the sensors, and you have the output variables. Okay, which may be the motors or relays or display devices. Okay, and the user interface is like keypad. Okay, it can be keypad or touch panel. All these are which you can give input to the microcontrollers or DSP processors. They call it as HMI. Okay, like machine interface, human machine interface. HMI stands for human machine interface and linked to other systems. So coming to the sensors, okay, input variables. Let's take the input variables, which is the input variables. Like there are a lot of sensors available in the market. You can check this website digikey.in or the company called robo.in who is selling more sensors in India as of now, and RoboKits, where you have category like analog sensors, which can be directly interfaced to an analog pin, or you need an ADC controller, or digital sensors. Okay, there are a lot of sensors available like vision sensors, temperature sensors, radiation sensors, proximity sensors, pressure sensors. Okay, these are transducers which convert one energy to the other energy and sends to the microcontroller either in analog or a digital format. Okay, and like force sensors, flow sensors, flaw sensors. These are the sensors which you can interface with the microcontrollers or a DSP processor. Okay, to an embedded system. These are the input variables to an embedded system design. And you also have you can also interface other devices. These sensors can be interfaced either with the GPIO, the general purpose input and output, or you can interface with the serial pins like the UART serial port, or it can be connected to the microcontroller via a Bluetooth or a Wi-Fi or a LoRa module. Okay, so these are the input variables. So user interface, it may be like usually it will be a 4x4 keypad or keyboard. You can interface keyboard interface directly with the microcontroller, PS2 keyboard and USB keyboard. And you can also interface the membrane keypads, touch panel. Okay, so there are different types, touch screen, okay, mouse. These are the user interface to the controllers. And output variables, you can interface actuators, relays, motors to the microcontrollers or a DSP processor, or you can interface display devices. Okay, like LED is a display device, 7-segment is a display device, and LCD, liquid crystal display, is a display device. TFT is a display device. Okay, and or you can also interface monitors like HDMI monitor or VGA. So these are the output variables. Okay, so these are used for display. It can display only the output from the microcontroller. Okay, so the input from the microcontroller is like the sensors which you feed input to the embedded system, and output which you could display on the you could display on these devices, 7-segment or LCD. Okay, so if this is clear, if the input variables, the output variables, and the input HMI, the human machine interface to the microcontroller is clear for you, just type clear in the chat box. Let's go for the next slide. Ibrahim, welcome. And Apuraj, welcome. I will take your questions at the end of the session. Just type clear in the chat box if you're clear with the topic. Okay. Okay. It will take 2 minutes of time to reach me there. Okay, so thank you, Sabarishwaran, thank you, Kitana, thank you, Hemant, thank you. Okay, so thank you so much. Okay, so coming to the selection of package, you have DIP package, dual inline package. So this kind of packages can be mounted by using a soldering iron. Okay, you have the other package like quad flat package or the SOIC package or PLCC package, which requires a soldering station, a temperature controlled soldering station. And you have BGA, the ball grid arrays, okay, which needs a oven. So whenever you choose a microcontroller or a DSP processor, you have to choose a package. Okay, some DSP processors or some FPGAs, they are available only on this ball grid array. They won't be available on the DIP package or quad flat package. The reason is when you have more number of pin counts, okay, so it is not viable to have it on DIP package or a quad flat package. Quad flat package, it can have a pins of 204 pins or 176 pins. That's the maximum pins which is available in the quad flat package. Okay, this is a quad flat package. So when the pins are when the pin count is more than 250 or 300, in that case, it is available only on this BGA, ball grid arrays. Okay, most of your mobile phones, they have this package. The ICs in the mobile phones, they have this BGA package, or the Pentium 4 processor, a general purpose processor will have this BGA package. When you choose this BGA package, the schematic design is quite complex, the layout design is quite complex, as well as it needs a oven, okay, to mount this IC on the PCB, printed circuit board, the oven will cost you minimum of 10 lakh rupees to 1 crore rupee. So you need a stencil for that. So it is an additional cost when you design embedded system design with the BGA. Okay, the soldering station, the QFP package, it needs some professional skills are required for soldering iron. So, to solder this IC on the printer circuit board, the DIP package is normal, which you can do it by using a soldering iron. Okay. The next is the hardware design flow. So the first thing to design an embedded system design is, the first thing in hardware design is to bring up the schematics. Okay. You'll be drawing the schematic on a schematic capture software, which can be, you can use ArcCAD, or you can use Mentor Graphics, or you can use KiCad tools, okay, where you can draw the schematics. The next is the PCB layout. Okay, so you'll be drawing the schematic symbol, okay, bringing the circuit diagram inside the software. And the PCB design, the next is the layout design, where you create the footprints, the actual size of each and every component. And when you draw the schematics, you'll be connecting all the nets, you'll be giving the wiring diagram. And the layout design, like where you link the footprints directly to the schematics, and you'll be drawing the layout. Okay, the next is the assembly and testing. So this is the hardware design flow. So whenever you design, for schematic design, there are some requirements. For layout design, there are some requirements. And for assembling and testing, you have to take care of the design for manufacturing Okay, that you have to take care when you design the schematics. You have to follow the design for manufacturing, as well as DFT and DFM. Okay, DFT stands for design for testability. Okay, you should have some placements where the testing people can easily test the board easily. Okay, so schematic is coming to the schematic design consideration. Okay, so is that clear? Is hardware design flow is clear? Like schematics, layout design, assembly and testing, and selection of packages. Is that clear? Just type clear in the chat box. Okay, is that clear? The window. Can you suggest any software? Okay, clear. Thank you so much. Okay, schematic design considerations. Akash, like I'll come to what is core in microcontroller tomorrow. Tomorrow sessions we have like the introduction to the Cortex ARM Cortex M4 architecture. I will the talk about the core in the microcontrollers tomorrow sessions. This answer is for Ankit. Okay, this answer is okay. So coming to the schematic design consideration, like the power supply design, the first thing is you have to take care of the power supply design. You can use a Texas Instruments Webbench designer, and you have to take care of the ground splitting whenever you have analog grounds and digital grounds. Okay, whenever you have high speed ADCs and DACs, you have to do the ground splitting, and your proper calculation of decoupling capacitor. Every VCC you should have a decoupling capacitor attached to the pin. So for that you have to avoid noise. The purpose of the decoupling capacitor is to avoid the noise which is generated by the other electronic components inside the board. Okay, so proper calculation of decoupling capacitor has to be done, and ESD protection diode to reduce the electromagnetic noise. Okay, interference noise, EMI noise. You have to do the ESD protection diodes for ESD sensitive device. These are the things which you have to take care when you design a schematic design considerations. The 5 points what I have given is very less. Okay, if you take out the requirements, I can give a lecture for schematic design consideration for 1 hour, which will have more than 100 plus points. Okay, so what are the when you started designing the schematics, what are the things which you have to consider? I have given only the few important points which is there, but the schematic design considerations itself will have we can have a lecture of around 1 hour. Okay, the next is the layout design considerations. You have to check the footprint's actual size, placement of components as per the schematics. Okay, so I'll be going much more detail about layout design considerations during the PCB design sessions, which is happening on day 11 to day 20. Okay, so placement of components as per the schematics, placement of decoupling capacitors close to the VCC pin, and length matching has to be done whenever you route high-speed memories like DDR, SDRAM. You can see serpentine routing. Okay, you can in some of the boards you can see serpentine routing. So that is for length matching. Let me show that what is serpentine routing. Just give me a moment. Let me check for. Okay, so this is an example for serpentine routing. Okay, the trace is bent in order to match the length. Okay, so whenever you route interfaces like DDR, SDRAM, all the address pins has to be on the same length to the controller. When you interface to DSP processor, the length has to be on same length. Okay, the wiring length should be on the same length. In order to match that, they use this kind of routing is called serpentine routing. Okay, serpentine routing. So length matching of high speed memories, avoid right angle traces during routing, and place high speed memory close to the processor. These are the layout design considerations. Again, in this layout design consideration, what I have shown is just for an idea what is layout design considerations, but there are many. Okay, there are many. So is that clear? Is schematic design and layout design consideration is clear? Just type clear in the chat box. I am waiting for a chat. Okay. Chetan Wagmare is asking, like, is BGA type package is cheap? Chetan Wagmare. So BGA is not cheaper. I will tell you what is the problem with when you choose a package with the BGA. You need a stencil which will cost you if you are in India, it will cost you 10,000 INR rupees just for making the stencil. Okay, and these are like BGA packages are not viable for a low quantity. Say, for example, if you want to design only 3 boards or 4 boards, it's not viable. When you want to manufacture 100 products or 200 products, in that case, you can go with the stencil, and there are assembly house separately for this for manufacturing. Okay, in India it is there. Even in China, like, you can go for an assembly house, like, because an individual cannot purchase a oven. Okay, so it will cost you like 1 crore rupees. There are certain instruments which is available for 3 lakh to 10 lakh rupees, but minimum, there is no device there is no machine which is available below 3 lakhs, or for, up to my knowledge, it must be like the cost should be from 10 lakh from the BGA. The cost should be for BGA machines 10 lakh rupees. 10 lakh. The minimum price is 10 lakh rupees. So you can approach an assembly house, but they need a stencil. So when you design a BGA, definitely it will increase your price. Okay, this is not viable for individuals. Okay, so most of the DSP processors, they will be available on BGA format, and like, if you take Raspberry Pi, the chipset is a BGA. Okay, the Broadcom chipset is a SoC. It's a BGA, so it's not viable. Okay, Yashwant is asking, explain once. Okay, I'll just repeat. So I'll just repeat for one more time for Code Hacker. I'll just repeat the schematic. Whenever you design the schematics, you have to take care of the power supply designer. Okay, there are a lot of softwares which is available to design the power supply design. The reason why I say power supply design is, so whenever you go with a DSP processor or FPGA, you'll have 2 or 3 supplies. Like, you need a 3.3 volt, you need a 1.2 volt for core voltage, and sometimes you also require a 1.8 volt. Okay, you need a multiple power supply voltages along the board, like 5 volts. So you can see in your laptops. So laptops, like, they will derive a lot of voltage. So 1.2 volt, 1.8 volt, 2.5 volt, 3.3 volt. So for that, you need a power supply design. Okay, there are softwares which is available. One problem with the web-bench designer with Texas Instruments is it only recommends the Texas Instruments part. Okay, it won't. Sometimes it might be quite. The cost would be quite higher than the other parts which is available in the market. Okay, but it will give you the entire schematics when you design a power supply design on using web-bench designer. Okay, the next thing is you have to do a proper ground splitting, otherwise your board will not be reliable. Okay, so whenever this ground splitting is essential whenever you have a high-speed ADC and high-speed DAC inside your design. Say, for example, if you have a camera interface, or if you have a camera interface board, or in that, or you have some like multimedia interface, like audio interface, where you have a high-speed ADC and DAC ICs. In that case, you will have analog grounds as well as digital grounds. You have to do a proper ground splitting. Okay, when you put a multimeter between this analog ground and digital ground, there will be a connection, but it has to be splitted and it has to be connected via a Farad bead. Okay, so proper ground splitting has to be done for the analog parts, and especially when you design with high-speed ADCs and high-speed DAC. And every VCC pin has to be connected with the decoupling capacitor. Okay, you can see a 0.1 microfarad or 0.001 microfarad. I'll show you what is decoupling. Those who don't know what is decoupling capacitor, let me show that what is decoupling capacitor on the board. When even it will be available even on Raspberry Pi. Okay. Let me show that. Just give me a moment. Okay. So these capacitors, okay, these kind of capacitors which is nearer to the microcontrollers or DSP processors are called decoupling capacitors. Okay. The purpose of the decoupling capacitor is to reduce the noise which is generated by the other electronic components, okay, which is available on the board. Like, it may be due to the inductor, or it may be due to the other electronic components or other integrated circuits, or any ICs will generate some noise. So the purpose of the decoupling capacitor is to reduce the noise which is generated by the other electronic components inside the printed circuit board. Okay, so this is one example. So the decoupling capacitor placement, you see, like, so these are decoupling capacitors. Okay, these are decoupling capacitors. So you have to derive a proper value for that. Like you have to go through the data sheet. Whenever you choose a microcontroller or a DSP processor or an FPGA, the data sheet contains what is the proper decoupling capacitor you have to populate with the VCC pin. Because usually what happens is when you take a 851 microcontroller, you will have one VCC and ground. But when you go with a quad flat package or a BGA package, you will have multiple VCC pins and multiple ground pins. Okay, in that case, you need a decoupling capacitor. If you don't have the decoupling capacitor, then the problem is if you populate 10 boards, 7 boards or 6 boards will work and 4 boards will not work. You don't know what is the reason. Okay, the circuit may be correct and everything will be correct, but the board will not work because of the noise which is generated by the other electronic components. Okay, ESD protection diodes for ESD sensitivity ICs is very mandatory, because there will be electromagnetic noise which will be generated. So in order to avoid that, you can see this ESD protection diodes on the USB pins, especially on the USB pins or on an Ethernet connector. Whenever you connect the microcontroller with an outside world, okay, you need this protection diodes to protect the IC. Okay, otherwise the IC will get damaged. Okay, so these are the schematic design consideration. Layout design consideration is check the footprint size and placement of components as per the schematics. I'll explain you how to place the components as per the schematics in the PCB design session. And placement of decoupling capacitors has to be done very close to the VCC pin of the microcontroller or a DSP processor or an FPGA. Length matching for high-speed memories. Okay, because whenever you connect a high-speed DDR memories with the microcontroller, the length should be same length. Otherwise, there will be a propagation delay. Okay, in order to avoid the propagation delay, in order to match this length, they will do a serpentile routing. Okay, intentionally they will introduce a delay on this line to match the length. So that is called length matching of high-speed memories, and avoid right angle traces during the routing and place high-speed memories close to the processor. Okay, that's all about layout design considerations. So coming to the software design flow, the hardware design flow will have the schematics, layout, and you will draw the once the PCB layout design is completed, you will be sending to the PCB fabrication unit. Okay, and you will be sending for stencil also, like stencil. Once that's a hardware design flow. The software design flow is where you write the code, where you have an IDE, integrated development environment. So the integrated development environment is a combination of the compiler, assembler, linker, everything put together. Okay, so put together, like where you'll be writing the code on C language, which through an editor window, the compiler and assembler will give you an object file, and this object file is linked to a linker. The linker will produce the final hex code, which the hex code is or ELF file is finally downloaded inside the microcontroller programming via any programming technique. Like it may be in-circuit serial programming, or you need any programmers, or you need an emulator to download the program inside them to program inside the hardware. Okay, software design flow. So coming to the embedded development lifecycle, like you have the compiler, you can choose. Sometimes most of the embedded system design is a simple super loop. It's a simple while loop. Okay, or in some cases you may require an RTOS operating. You need a real-time operating systems to manage the embedded systems, and you networking protocols, check for the networking protocols, Java support, graphics supports, project code management, RTO simulation. All these are software. Okay, hardware selection, you'll be choosing the right processor, like microcontroller or DSP processor or FPGA. Schematic hardware coverage is schematic design, layout design, bringing the board, test for design the board for testing and source level debugging. Like okay, then integrate both the software as well as the hardware, and you will be doing the real-time debugging. Okay, real-time debugging, like profiling, execution profiling, data visualization, memory leak detection, and post-mortem debug is where you deploy the whenever you deploy, you'll be deploying the board on the field, and if anything happens on the field, they'll go for the post-mortem debug. The post-mortem debug is more familiar on the automotive infotainment, like on the cars, like when a crash occurs, like they go for a post-mortem debug. And even in aircraft, like whenever an aircraft crashes, they go for a post-mortem debug. So what causes that failure? Okay, they will go for the debug. So even though when you test it on the field, when you test it on the research and development on your lab, the board will work fine. But some cases due to the external environment, that may cause failure to the board. that you can find out only on the post-mortem debug. Okay, in case, because whenever you design an embedded system designed for a hard real-time systems, like the lift, even in an elevator is a hard real-time systems, because missing a deadline may cause an havoc. Okay, something happens, so that will kill the person. Okay, so the aircraft or the nuclear reactor. So in that case, post-mortem debug is absolutely necessary in order to find out what made the crash and to rectify the circuits back again. Okay, and in-field debugging as well as the post-mortem debug. Okay, so these are the embedded development life cycle. If this is clear for you, just type clear in the chat box. Okay, I'll go through the chat. We'll cover up what is simulation, evaluation, emulation. Is that clear? Is that clear? Just type clear in the. Yeah, Hemant, you're right. Decoupling capacitor is used to reduce noise and voltage fluctuation. Okay. Sheikh, the class will end at 7 o'clock today. It's 1 hour. The class is for 1 hour. Okay. Only the first day will go for the 2 hours. The class is for 1 hour. So thank you, Charandeep. Thank you, Likita Sai. Thank you, Navya. Thank you, Vekat. Thank you, Deepak Kumar. Thank you, Kalvili. Thank you, Sanjeev. Thank you. Okay. Rajkumar, thank you. Tangeshwari, thank you. KS Mahendra, thank you. Darkness Writer, thank you. Vivek, Fun Electronics, thank you. Raj, thank you. Okay, so simulation is a process. It's a process on embedded system design where you no need of any hardware. Just like the Proteus is one example for simulation. Like you just drag and drop every component, connect the components, and you can verify. Okay, this will speed up your design. Okay, to verify the design, whether the design works or not. Once you complete the simulation part, the next part is the evaluation part. Okay, evaluation is where most of the manufacturer they have their own evaluation boards. You can purchase these evaluation boards. The Nucleo F411 is one best example for the evaluation boards. Like I'll show the boards probably on tomorrow or day after tomorrow. Okay, so most of the microcontrollers they have the evaluation boards from the manufacturer itself. You purchase this board, download the source code what you have developed, and you check whether the project is working fine or not. Once the evaluation is completed, then you can go for the emulation, which is the board designed by you. Okay, in that case you need an emulator. Emulator is a hardware. It's a hardware which you need, where you have to connect this emulator via to your board, to your own design board via a JTAG, and you will be keeping breakpoints, and you can test whether it is working or not. Okay, so that process is called emulation. Okay, you will download the code, and you will be debugging the board. Debugging is nothing but like testing the board and keeping breakpoints, stopping the program at various places, halting the CPU operations, and test whether you meet the requirements. Okay, so that is called emulation. Simulation, evaluation, and emulation. Evaluation is a board manufactured from the manufacturer itself. You can purchase this board and you can test the design, because the manufacturer itself will provide you the right schematics and data sheets. They will provide the lot of things. Okay, so when you design a product for the first time, you just go with the evaluation board. Once the software design is completed, then you can go for your own design, which you need an emulator for testing this board. Okay. So cabinet design, like once for your embedded design, you can use 3D printer special, but this is not viable for more number of products. In that case, you can go for mold. Okay, so the other thing is the laser cutting machine, which you can use for cutting. You can use sheet metal boxes, or you can use even acrylic boxes. Okay, so that laser cutting and CNC machines and 3D printer. And test zig, this is an equipment which is required whenever you test more number of products. Okay, say for example, if you want to test 1,000 products in one single day, then manual testing is not possible. Okay, so the schematic designer, it's the guy who is designing the board is responsible for designing this jig. Okay, so he should design a jig such a way, like so that even a diploma person or even non-skilled labor can test the board. Okay, when you walk into the lot of mobile companies, you can see a lot of non-skilled laborers testing the high-end mobile phones, because they use this jig. Okay, so most of the testings are done by robots, like where it runs the test sequence on the processor, and it checks for the sequence. If anything happens, it will give you the right solution for it. Okay, so the designer is responsible. It is the designer responsibility to design zig. They'll be using like a lot of pogo pins will be there, like pogo pins where it you can so you have to draw the schematics, you have to keep the test points when you draw the schematic itself. Okay, when you draw the schematics, so that is called design for testability. Okay, so that is so whenever you design a products for a standard certification, like for a standard certification like CE certification product, CE certification product, or FCC certified product, in that case, you need to follow the requirements followed by the standards, international standards, for design for testability as well as for design for manufacturing. Okay, so that your product should be easy to manufacture and easy to test. Okay, so test zig is used for testing. By using this zig, you can even test 100 products or 1,000 products in one single day. Even a non-skilled labor can do the job. Okay, so that is test zig. So, okay, coming to the IDE, integrated development environment. So, it is a combination of compiler, assembler, linker, and loader together. So, most of the times, the IDE will be supplied by most of the manufacturers. Okay, if you take ST Microelectronics, they have STM32Cube IDE. If you take Texas Instruments, they have Code Composer Studio, Analog Devices as Visual DSP, and so Microchip, they have their own IDE. So there are also third-party developers of that. Kale is a third-party developer. Okay, so there are third-party developers who take the open source compilers like GNU compilers and they integrate it and they form this IDE. Okay, so compiler, assembler, linker, loader together. So it will have an editor window where you can type the program, the C program, and you have a console window where you can see the output of the program. And you have the project window where you can organize the projects, because most of the times your project will have a single C file, or it can have a multiple C files. Okay, or you can have C and assembly together, or you can have C file as well as a C++ file. Okay, so you will have multiple files. In the linker file, you will have the startup files, startup codes. So that is the project window allows you to manage the different files, the header files allows you to manage the header files as separate. All the source files are separate and all the linker files and assembler files are separate. Okay, so that's the advantage of project window. And coming to the debug and release, so whenever you're writing the code, okay, so it should be on the debug environment once the code is done, and whenever you go for the manufacturing, it should be on the release environment. Okay, in all IDE you can see the debug option as well as the release options. When you keep it on debug option, the compiler will generate the debug symbols necessary for the debugging. Okay, when you put it on the release mode, it will generate the optimized code. There will not be any debug symbols at that point of time. Okay, so it will give you it will be optimized for programming. Okay, whenever the product is ready for manufacturing, then it's better to go for the release option and you have to give it. Fourth point is the memory window. So most of the IDE has this memory window because you can view the values which is stored in the microcontroller memory as well as the memories interface with the microcontroller, SRAMs or SDRAMs, or that option is there. And register window, you can see the values of the registers because every microcontroller will have the registers. Okay, they will have some special function registers, they will have some core registers. So you can view the registers values on the register window. And breakpoints is an option on IDE which is used to stop the execution of the program. Okay, so you can keep breakpoints, and sometimes depending upon the IDE, the breakpoint is limited. Okay, in STM32Cube IDE, you can have 6 breakpoints. It means you can stop the program at 6 different locations on your program. Watch points is used to stop at certain whenever a certain condition is met. Okay, so for example, like when the data is right on a certain variable, if you want to halt that at point, then you can use watch points. So debugger is a hardware. Debugger is a hardware which is interface with the microcontroller or FPGA, which allows you to debug the code which is there. Okay, so the IDE will handshake the debugger. The IDE should allow a handshake with the external hardware, the debugger. Okay, so that option is there. And programming options. In sometimes IDE itself has the programming options. In some cases, it is not. Okay, if you say, for example, if you take a Norton 850 microcontroller, you need an additional utility to download the program. Okay, the Flash Magic, especially when you go for NXP microcontrollers, you need a Flash Magic tool to download the program to the chip. So that would be a separate utility which will not come inside the IDE. but there are certain IDEs which will have the programming options either through JTAG or serial wire debug. Okay, so these are the options. If this slide is clear for you, what is the ID is clear for you, just type clear in the chat box. If you have any doubts or if you want me to repeat this topic, just type repeat in the chat box. Okay, I'll go through your chat and go for the next slide. Check this. This session will end at 7 o'clock. Shabaris, the jig is for testing. Okay, the test jig is for testing, testing more number of boards. This jig will be helpful whenever you manufacture more than 5,000 products, and when you have some delivery timeline, like which you have to deliver the boards within a certain period of time. In that case, you need a test jig. Okay. So Kunjan is asking for repeat. Okay, so I see 1 repeat, 2 repeats. Okay, 3 repeats. Okay, 4 repeats. Okay, let me explain this IDE. So IDE stands for Integrated Development Environment, which is a combination of compiler, assembler, linker, and loader put together. Okay, so inside this IDE, you have the editor window where you can write the C program or C++ program. And you have the console window where it will display the output on the console window, and the project window where you can organize the projects, because your project can contain one C file or multiple C files or multiple header files, or it will have a linker file. So everything, in order to organize this, you have this project window, and there are 2 options on the IDE. During the 4th day, on the day 4, I'll be creating how to create a project on STM32Cube IDE. In that case, I'll explain you what is debug and what is release. I'll show you what is debug. When you compile the code in debug, how it would be, and when you compile the code release environment, how it would be. I'll tell you the difference between debug and release. Debug will generate debug symbols necessary for debugging. Debugging means to test the code. Okay, release. So whenever you go for manufacturing, once the testing is done, you should keep the settings, project settings on the release window, and you have to give so that it will not generate any debug symbols. Okay, it will be the optimized code. The memory window and register window is used to view the values of the memory stores, the value stores, any value stored in the memory, and register window which allows you to store the register values. Okay, breakpoints stop the execution of the program. I'll show you on the demo class on day 4. And watch points is also used to stop at a particular, when the condition is met. Okay, the difference between breakpoints and watch points, both are used to stop the execution of the program, but watch points, when a condition is met, you can stop the program. And debugger is used for debugging. Okay, and programming options, in some IDE programming options is available. Okay, in some IDE it is not. You have to ensure with the IDE whether the programming is there or not. Otherwise, you have to find out the utility. It will be available from the manufacturer to download the hex file or to download the ELF file to the microcontroller. Okay. So coming to the software development flow, like you can see the C++ source file which is sent to the compiler. Okay. And where you have an assembler source which converts that to a ASM file, which is sent to an assembler file, assembler which provides which converts that back to an object files. Okay, the object files is when you give to the linker will provide you the executable file, the executable file will be downloaded to the microcontrollers. Okay. So hex conversion utility, like you can, if you want to download to a EEPROM programmer, you can use the hex conversion utility. Okay, so you can also, if you want to link as a lister file, it means like a library file, it is also possible. Okay, so macro source files or header files which is used in the projects, that will be linked to the assembler. Okay, so this is a software development flow. So the linker description file, most of the time, like the compiler uses the default linker. Like say for example, when you use an Arduino IDE, you don't know what is linker file. Okay, most of them don't know, they don't know to edit the linker file. Okay, because it uses the default linker which is available inside the IDE. The problem with the linker is whenever you interface in the external memory and the code overlaps, the code is not sufficient. The on-chip memory is not sufficient. Whenever the on-chip memory is not sufficient, in that case, you should know how to edit the linker description file. Otherwise, we cannot compile the project. Okay, so the linker description file will tell you which program has to store on the program memory, which part of the code has to be stored on the data memory. Okay, so how many of them know to edit their linker file? Just type me in the chat box. If you don't know, just type don't know DNK in the chat, don't know in the chat box, DNK in the chat box. Okay. How many of them know how to edit a linker file? If you don't know, just type DNK. Okay. If you know, just type yes in the chat box. Yes. Yes. Video will be available for 3 days. Your video will be available for 3 days. You can go through it. Okay. Okay, lot of people they don't know to edit this. Okay, see, I'll tell you what. See, the C program has different sections. Okay, you can just search for .bss, like what are the sections on the C code. BSS global variables, BSS dot C in it. Okay, and you have the local variables, and you have the .text and .cio. These are the different sections. Okay, block started by BSS stands for block started by symbol. It means these there are certain variables should be stored on the RAM space. Okay, on whenever you go for a microcontroller, there are two types of memory available. One is the flash memory, which is non-volatile. The other is the volatile memory, which is the RAM memory. Okay, so when you do arithmetic operations, so the program variable, the variable value will be changed. So you cannot store it on the flash memory, because the way you read and write the flash memory is quite different. Okay, flash memory is non-volatile. It means whenever you power off the microcontroller and when you power it back in on again, the program will be there. Okay, the program code will be there. But so what happens is, but you cannot store this. You cannot. But when you do some math operations, like you cannot write the flash memory from the C code. That is not possible. Okay, the controller cannot write the flash memory from the C code. It needs a programmer to store or edit the memory, the flash memory. So what happens is, it will store it on the RAM memory, which is available on the microcontroller. The RAM is volatile, okay, which the microcontroller can edit easily, where the core can be edit easily. Okay, so certain part of the code has to be stored on the flash memory, certain part of the code has to be stored on the RAM memory. Initially, the entire C code will be stored on the flash memory because the program has to be there. But when the process start execution, okay, the startup code on your project, there will be a code called startup code on your project. The responsibility of the startup code is to copy the contents from this flash memory and to load that contents on the RAM memory. Okay, that is the functionality of the startup code. Okay, so this, like when you have a design like this, embedded design like this, when you have an internal RAM, a DDR2, that's an volatile memory. Internal RAM is also volatile memory and flash memory. So the .text sections and .cnit sections, it has to be stored on the flash memory because it must exist after reset. Okay, whenever you reset the processor, the program will erase. If you store it on RAM, okay, when you store the program on RAM, the program will erase. So that content has to be stored on the flash memory. Okay, .cnit has to be stored on the flash memory, and .bss, block started by symbol, and .stack. Okay, so those sections has to be stored on the RAM memory. Okay, so this description will be there in the linker file. So so .text, .switch, .constant, .cnit, pnit has to be the initialized memory. The memory type is initialized memory. It means a flash memory. BSS for stack, CIO, or uninitialized memory, which has to be stored on the RAM. Okay, so the linker file, the language will be quite different for manufacturer to manufacturer. If you go through the versions, I'll show you the sample linker file. This is a sample linker file from DSP processor from Texas Instruments. The sample linker file for ARM Cortex M4 series on the ST microelectronics will be quite different. The visual DSP, when you go for the analog devices microcontrollers, it will be quite different, but the functionality is same. Okay, you will have the memory description. Okay, memory description will tell you what are the memories available on your embedded system design, and you have a software sections which will tell the different types of sections available on the code, on your C code. You can also have your own sections, okay, because these sections are default sections from the manufacturer itself. The .text, .switch, .constant, .cnit, .pinit are the default sections. You can also have your own customized sections. That is also possible, okay. So these sections has to be defined on the software sections. So on the code, on this linker file, you have to mention the starting address and the ending address of the memory you have, because the processor will not know like what memory you have interface with the microcontroller or microprocessor. Okay, you have to define it on this linker file. Where either it is flash memory or DDR or flash, what is the starting address and what is the length, what is the size of the memory. That should be described at the linker file. Okay, and the section file will tell you which section has to be placed on the which memory. Okay, RAM memory, like BSS to RAM memory, .far to RAM memory, .text to DDR, double data rate. Okay, so these are the different types of memory. So you have to map the sections to the appropriate memory. Okay, so that has to be done on the linker description file. Okay, I will explain you much more detail of the linker description file when we go for the programming part. Probably on day 4 or day 5 part, I will explain to the context of STM32Cube for the ST microelectronics. The concept is same for other microcontrollers also. Okay, so that you can familiar of how to write the linker file. You have not come across on Arduino because the Arduino uses the default linker. Okay, the problem with the default when you use an on-chip memory, when your application fits on the on-chip memory, there is no problem. You can go with the default linker. But when you have a complex embedded system design where you interface memories with the microcontroller, in that case, you need to know how to edit this linker file. Otherwise, you will not succeed in designing your embedded system design. Okay, you should know how to edit this linker file. Okay, so I will teach you on much more. So since we are running out of time, I will please go through the video. It will be available for 3 days. Okay, I can even extend more than that for 4 days, but not more than that. Okay, so you can. So if you have any doubts on that, you just comment it on the YouTube comment box. I'll go through your comments and I'll reply back. Okay, so coming to the programming techniques. If this is clear, till this point, if you're clear till this point, just type clear in the chat box. Okay. Okay. Is that clear? Just type clear in the chat box. Thank you, Nitish. Thank you, Ujjwal. Thank you. Okay. So coming to the programming techniques, the attendance will be available at the end of the session. Okay, just wait for 10 more minutes. We'll complete. Okay. Okay. So the programming techniques, like ISP stands for in serial programming, where you can program the microcontroller through a serial port. Okay. ICSP stands for in circuit serial programming. Both are same, and IAP for in application programming, where the device will be on the remote place and you can program through Wi-Fi. Okay, just like your mobile phones or your set-top boxes. Okay, where you can program it through on the air, over the air programming. So it's IAP is also called over the air programming. Okay, so you design the controllers, you make delivery to the customers, and you can upgrade the patches. You can upgrade the code via over the air. Okay, that's possible on in-application programming. And JTAG is for Joint Test Action Group. Okay, which is for programming for the via JTAG protocols. Okay, so these are the different types of programming techniques, and I have not included serial wide debug. SWD is also there, which is a proprietary for ST microelectronics programming techniques. Okay, so JTAG, like TCK, TMS, TDI, TDO, TRC. So these are the pins and these are the emulators, different types of emulators available in the market. Okay, so coming to the common embedded peripherals, what are the peripherals available on microcontrollers or DSP? So these are the peripherals, like you have GPIO controllers, general purpose input and output, which can be used as an input pin or an output pin or an analog pin, or it can have alternate functions. Okay, and you have timers. In timers, like timers are mostly used for delays. Okay, and for counters, it is used as a counter to count an external events or to generate a delay. Timers. Pulse width modulation to generate a timing signals, which is used for controlling motors. Okay, pulse width modulation. And DACs, digital to analog converters, it can be available on chip, and ADC, analog to digital converters. And serial communication controllers are there, like UART is there, universal asynchronous receiver and transmitter, and SPICE serial peripheral interface protocol, I2C, inter-integrated communications, and Ethernet. Okay, these are the serial communication controllers. And memory, you have two types of memory, primary memory and secondary memory. I'll come up in the next slide what is primary and secondary memory. And interrupt controllers, you have interrupt controllers, because when you how to manage interrupts, different types of interrupts. Okay, ST microcontroller can manage, the ARM Cortex M4 can support up to 240 interrupts, 240 different interrupts. You can give priority with that interrupts. If you don't know what is interrupt, I'll cover up that in much more detail on the interrupt session on day 7 or day 8. Okay, and direct memory access controllers, DMA controllers, where the peripherals can control the other devices via this with the memory or via a DMA without going for the CPU. Okay, direct memory access controllers and control area network and local interconnect network and JTAG, USB, video ports, and audio port. These are the common embedded peripherals which is available on the microcontrollers. I might have missed some of the points, some of the peripherals, but most of the controllers has this same thing. Okay, there may be some cases that may be some different, but we can explore later. Okay, so memories, basically there are two types of memories, the primary memory and the secondary memory. Primary memory is a volatile memory, which means when you reset the processor, the program will be erased, like SRAMs and DRAM, but it will be high speed. Okay, the secondary memory is the flash memory or EEPROM, electrical erasable programmable read-only memory, or PROM. Master ROM is one-time programmable. Okay, so these are the different types of memory which is available for the embedded system design. So based on your application, you have to choose. So if you have a lot of variables, if you have whenever you do a complex image processing application, in that case, when you have a lot of coefficients, in that case you need a lot of dynamic random access memory, DDR SDRAM, to process those variables. And when you have more number of stacks, okay, so you have to choose the right memory and with this right size when you choose when you design an embedded system design. Otherwise, if you have not allocated a sufficient space for stack, then it may cause you a stack overflow. Okay, so the memory calculation has to be done. You have to do a math and how many variables you are using, what is the length of the variables, what is the data which you are going to use. Based on that, you have to decide the size of the memory which you have to interface with the embedded system design. Okay, so I'll just go for just give a short recap of those UART, SPI, and I2C. Okay, and we'll be completing within 5 more minutes. I will not take more than that. Okay, probably we'll complete within 7.5, not more than that. Okay, so what is UART? What is UART? Like, UART stands for Universal Asynchronous Receiver Transmitter. It is called serial port or COM port or RS to the port base, which is for serial communication, which is used to interface microcontroller with the other peripheral. Like, you can interface with the Bluetooth controller, or you can interface with the Wi-Fi controller, or you can interface with the microcontroller to microcontroller, or microcontroller to PC, personal computers, or laptops. You can use this. The maximum distance you can cover up is 3 to 10 meters. Okay, if you want more than that, you have to go for RS485. But it's recommended to communication for 3 to 10 meters. That's for UART, serial communication. Okay, so mostly like you will have a transmitter, has to be connected to a receiver has to be connected to a transmitter. That's cross communication. Okay, so you have the transmitter part which is connected to the receiver part, and receiver part which is connected to the transmitter, and it's full duplex communication. Okay, coming to the SPI, serial peripheral interface, it is also a full duplex communication. You can both transmit and receive data. It needs 4 wires. Okay, so 4-wire communication protocol. One can be master, and you can have multiple slave. There is no multi-masters and multi-slave. Okay, here only 2 devices can communicate. You cannot interface more than 2 devices to UART. That will go for the bus contention issue. Okay, and SPI, you can have more devices, but only one device can act as a master. That is the advantage. Very short distance, less than the UART. Okay, SPI is recommended for onboard PCB communication. Okay, and so you will have this like serial clock. The clock will be connected to multiple slaves. MOSI is connected to MOSI, master out, slave in, master in, slave out. Okay, and you have an additional chip select. Chip select is used for SS pin, is for slave select pin, which is used to select the slaves. Okay, so you need an additional GPIOs to select multiple slaves. That is the disadvantage of this SPI communication. For example, if you want to interface 10 slaves then you need 10 GPIOs. That is the disadvantage of this communication. Okay, whereas the I2C communication, it only uses only two wires for communication. One is serial clock, other is serial data. So there is no chip select lines, but it can connect up to 1,000 devices. Okay, you can interface up to 1,000 devices, but it's half duplex and multiple master, multiple slaves. Okay, it has a bus arbitration. This protocol has a bus arbitration. It means any device can act as a master and any device can act as a slave. Okay, this is phenomenal. The I2C is working, is phenomenal, but it's half duplex. Okay, it's not full duplex, it's half duplex. Either transmit or either receive. That's a one disadvantage. So coming to the test, the video will be available. I'm going fast because like we are running out of time. So I'll take only 5 minutes, okay? And then we'll close the session. Test and measurement requirements for ESD. SMD tester you need for especially for capacitors, because the resistors will have, you can find resistors with whenever you go for SMD test, SMD resistors and capacitors, you can find it, the SMD resistors, there may be a short code on it which you can find through the lens, but the capacitors, you cannot find out the value of the capacitors. In that case, you can use the SMD tester. Okay, and multimeter, you have logic analyzer which is used to logic, and protocol analyzer which is used to analyze protocol like I2C, UART, and SPI protocols, the timing waveforms which is to analyze, and DSO. Okay, so there are devices like there are a lot of devices which is available. Like all these things are available on a single device. If you can purchase that, please do that. It's worth investing. Like if you want to design if you want to become an embedded system designer, that's worth investing. Okay, and short circuit locator, especially when there is a short circuit issue on your board, this short circuit locator it will help you to find out where the short is. Okay, because that's if you ask to any test engineer, short circuit is the biggest issue they found it on the embedded system design. Okay, for that you have to go for short circuit locator. The attendance will be available on the link within 5 minutes. Okay, no need to type present. If you type present, then I will disable the chat. Okay, so this is for learning. The attendance will be open for 5 minutes. Okay, within 5 minutes. Please don't type present in the chat box. If you are going to do that, I will be disabling the chat box. Then there will not be any communication. Okay, please don't do that, because I may miss the chat. For those who are listening, I may miss the chat. I may miss their questions. Okay, if you're coming only for the certificate, the link will also be available on the description after this session. Just come and post attendance and you can go back. Okay, please don't disturb the people who want to listen and who want to attend the program, who want to learn. We are giving it for free because there are certain students who are not able to afford this cost, even this 1,000 rupees. For them, it's free, and they can ask post the questions in the chat box, and they can meet me on live. Okay, so if you put present, and I may miss them chart, and you are disturbing the learning process. Okay, please don't do that. Sorry for this 1 minute of time. Okay, so coming to the functionality tester, like which is used for the in-circuit functionality, is used to test the in order to test whenever certain integrated circuits is not working, you need this in-circuit functionality tester to debug the board. Okay, to debug the board. And coming to the JTAG testing, okay, it is also used for testing these boards. Okay, so I will cover up this operating system on the later sessions, because I see a lot of people coming only for the attendance. Okay, so I just recap what we have covered today. The basic elements of embedded system design we have covered up, like compiler, assembler, linker, and loader we have covered up, and the programming techniques we have covered up. The ICSP programming, in-application programming, and JTAG programming we have covered up, and the compiler, like software design flow and hardware design flow we have covered up. Common embedded peripherals we have covered up, and test and measurement equipments we have covered up. Okay, I have not covered this basics of ATOS as due to the time limitations. Okay, so let's cover up on one more day. Let's go for the mindset lesson. So we have extended the offer today. So if you want avail this offer, you can avail this offer. So we'll be disabling it tomorrow. Okay, so thank you so much for your time, and let's go for the mindset lesson. I asked my team to post the attendance link on the chat box. Please post the link on the chat box. This is for my team to post the link, the attendance link. So those who so today's mindset lesson is about the session is over. Okay, so the next is the thank you slide, and I'll take this mindset lesson for 2 to 3 minutes of time. To if just give me permission, P for permission for the mindset lesson, P for permission for the mindset lesson. Can you please suggest some of the components that which you can? Yes, Chetan, I'll tell you on the next class, on the lab session. I'll tell you what are the things which you want. Okay, I have also tell same thing on the yesterday session. Just go for a starter kit there. Okay, all the components that in the starter kit you can purchase. This answer is for Chetan. Okay, so attendance link is there. I will pin that attendance link on the chat box. Okay, so those who just type P for permission for the mindset lesson. Okay, Ganesh. So this lesson is for those who type P. Okay, P. I would like to thank them and I would like to welcome them. Like Pradeep, thank you. Anurag, thank you. Mohan, thank you. Mohan is for present. Okay, Nitish Sharma, thank you. Ujjwal, thank you. Nikunj, thank you. Breakthrough Innovation, thank you. Deepak, thank you. Rahu, thank you. Abint, thank you. Kaushal, thank you. Mukesh, thank you. Syed, thank you so much. Nagraj, Anurag Tiwari, thank you. Okay. So thank you. Pradeep Mohan, thank you. I do see, please use the PCB board. Okay, don't use it for Excel communication, like for the which is inside the PCB. Prevention, like use it for PCB inside the printer circuit board. Okay, so thank you so much. Okay, so let's start the mindset lesson. So I'm going to share a video called "Strangest Secret in the World." Okay, I want just give me a moment. Let me share it on the chat box. I want you to go through this video. This video is released in the year 1960s. Okay, from Strangest Secret, which is from Earl Nightingale. So this video has created. Just give me a moment. Let me share it on the chat box. Okay, I'll share your video. Anyone who wants to become a millionaire, you have to go through this video. Okay, so this video has created a lot of millionaires in the United States. I just share the video called Strangest Secret. Okay, so I just shared the video called Strangest Secret on the chat box. This is for 30 minutes. I want you to listen at least once. Okay, if you ask me like how many times I have listened to this video, more than 300 times, more than 6 months. Okay, and I have a membership called Diamond membership where they pay me 1 lakh rupee for consultation. Okay, so the first task I gave to them is to listen this audio file for daily. Okay, the Strangest Secret in the World by Earl Nightingale. Okay, I want you to listen this audio because you become what you think. Okay, so your thoughts are much more powerful, which you can create. Okay, the best things in the planet, and it can also create the worst things on the planet. Okay, your thoughts are much more powerful, so you have to control your thoughts. Okay, you are the product of your own thoughts, and if you want to change the result, say for example, if you want to become a millionaire, the very first thing is your thought. Okay, your thought will create the feelings, your feelings will create the actions, the actions will create the results what you want. Say for example, if you want a job, if you want only the job. Okay, so if you think like your thoughts, if you have a thought like if you have a positive thoughts towards your goal, you will have a positive feelings, which the positive feelings will take a positive actions, and this positive actions will get the results. Say for example, if you're not getting a job, if currently you're trying for a job for a long time, and if you're not getting the job, it means your thoughts are not in the right way. Okay, you have to take an audit of a thought, whether it is positive or negative. If it is positive, you will get positive. If you think in positive terms, you get positive results. If you think in negative terms, you will get negative results. Okay, so I want you to watch this video, Strangest Secret, at least once. Definitely that will change your life. Okay, that will change your life. If you my advice to you is you want to listen it daily for at least for 30 days daily. Okay, because every time you listen you come up. That's the reason like we made it with the subtitles, the audio file. It actually is a radio talk. I made it as we made it with the subtitles. So you just go through the subtitles and you just listen to the audio. Okay, the strangest secret of the world. This audio has created a lot of millionaires in United States, and it also created a lot of millionaires in India. So if you want to live a lifestyle you want, you go through this audio. Okay, so this will give you clarity about your thoughts, about the creator mindset, whether you go with the competitive environment or a creative environment, what type of environment you have to choose, what type of mindset you have to choose, the creative mindset or a competitive mindset. Okay, so and what, so if you have jealous, if your thoughts, if you're having fear, if you're having jealous, if you're having anger, in that case you're going to attract the same thing. Okay, you're going to attract the same thing and you will get the same results. Okay, if your thoughts are going to be joyful, and if you're going to, if you're joyful, and if you're going to be like passion, in that case you are going to get the positive results. Okay, so you have to take audit what kind of thoughts you have and whether it is positive or negative. So whenever it is negative, just stop thinking. Okay, it's like consuming poison without knowing that's a poison. Okay, so having a negative thought, it's just like consuming poison without knowing it's a poison. Okay, so the same thing was you are the point of your own thoughts was said by Mahatma Gandhi, and there are a lot of people, the words which is written in all the holy books like the Bhagavad Gita or the Bible or the Quran. Okay, so everything is same. It's all about the thought. Okay, the thought can create, the thought can destroy. Okay, so it's just like a double-edged sword. Okay, if you use it in a positive way, you can use it for positive things. You can, if you use it in a negative way, that may cut your hand. Okay, so take an audit of your thoughts. So this is the lesson which I'd like to share you today. Okay, please do go through this strangest secret in the world, Earl Nightingale. Okay, which will if you, especially when if you want to change your lifestyle, if you don't like the current lifestyle what you live, the current, please go through the audio at least once. Okay, that will give you more insights. So thank you so much for your time. I'll take your questions on the chat box. So after that we'll close the session. So just type your questions on the chat box. I'll take your questions. So first I'll take from Pradeep Benukonda sir. I'm having only basic knowledge of MC, microprocessor, and FPGA, and this course I am able to understand very little, and I'm interested in embedded job. How I can apply to reach this? Pradeep, the only thing is consistency. Like you have to learn consistently. Okay. Everyone is a basic. Like we started the embedded company without knowing what is microcontroller, what is DSP, and what is FPGA, and we learn to manage it. Okay, we learn to design our own products. It's all about your will. Okay, so everything is a learnable skill. Okay, even programming is a learnable skill. Okay, you just practice, and on a right way you will get. The thing is, unless you practice, you won't get it. Okay, so you have to invest money for that. Say for example, to buy the boards and everything. Okay, so first decide exactly whether you want to get this embedded job. If you want that job, then do the necessary investments for that, because you might be spending for the entertainment, for movies, or for any outings. You cut down some of the costs and do some investments for setting up a lab on your home. There are a lot of ways you can generate passive income with the content. It's not only the job. Okay, when you try for a job, you can also make a lot of passive income by writing a blog post or putting the content what you create, and you can earn. Okay, so money. So Pradeep, this answers for Pradeep. And approach is so what maths is so much required to become an electronics engineer? What maths structure? So approach like so if you go for the analytics or data science, or you may require a complex math. So if you go for any algorithm design, the software design, like you may require the mathematics. Okay, but it's not a big deal. Okay, it's not a rocket science. You can easily acquire the skills. It's not. Kevin, I'm able to assemble and test the PCB. What are the other skills required to get a job as a PCB engineer in reputed companies? Kevin, you please, Kevin Hari, like it's better to learn BGA. Okay, unfortunately, we don't have a course on BGA as of now. But but you can learn BGA. Okay, BGA routing, like BGA routing, especially if you're in PCB layouts. Okay, if you are a test engineer, definitely you have to migrate for either to hardware engineer or to migrate to software engineer or to PCB design engineer, because testing engineers, like there won't be much growth when you go for down the line for more than 5 years or 10 years. Okay, in that case, it's better to migrate to a hardware design engineer or a software design engineer. If you want to become a hardware design engineer, then you have to learn the microcontroller skills. If you want to learn a PCB design engineer, then you have to learn the routing skills, like high-end BGA routing. Okay, BGA high-speed design ports. In that case, you can even get 1 lakh rupee or 2 lakh rupees per month. Okay, that is possible. This answer is for Kavin Hari. What company, like Kavin Hari, Omkar, what ID software we should use? Omkar, this answer for, we are going to use STM32 Cube ID. I'll share you how to download that. I'll share you the link. I'll tell you the 8 days, 7 days we'll be using that software, STM32 Cube ID. I'll share you the link. Okay, you can download it. It's free. But some of the codes you cannot run you can compile it, but you cannot download because you need the hardware. Okay, this answer is for Omkar. If you can purchase the hardware, you can purchase the hardware. That's so. JJ, what is the instrument which is used to measure everything? Which is okay. JJ David Stephen, JB David Stephen, like you can check for analog discovery kit. Let me show that analog discovery kit. Okay, which has everything. Okay, so this one analog discovery kit, which has the logic analyzer. Okay, 75 in stock you can get from Digital. So one thing is analog discovery kit. The other thing is you can use AD. Just give me a moment. Okay, you can use analog devices. You have ADLM 2000. Okay, let me check this. Sorry, ADLM 2000. Okay, sorry, ADLM 2000. Sorry, it should be. Let me check this. Analog discovery kit is there. If you want ADLM 2000, sorry, ADALM 2000. Okay. So ADALM 2000. Okay, if you check this, you have this answer is for David Stephen. Okay, you have the DSO part and spectrum analyzer. You have the logic analyzer, protocol analyzer. Everything is there in ADLM 2000. Okay, this one. Okay, even voltage regulator is there. Okay, you can generate 3.3 volt, 2.5 volt, and 1.2 volt. I want you to check this one. This answer is for David Stephen. Okay, how we split ground. Likita say how we split ground in PCB using same cell. Okay, so like you have to assign the analog ground and digital ground. Like when you do this routing, like ground filling, when you route the ground filling, you have to select shapes for that, and you have to split. And when you connect this, when you need to interface, before that in the schematics you need to have a ferrite bead which connects the analog ground and digital ground, and you have to, during the layout process, you have to take care of that. You just frame that analog ground as a separate island. Okay, and you connect that to a digital ground via a ferrite bead. This answer is for Sonu Verma. Okay, it's AK time. Give some tips to how this answer is for AK time. I have a separate program for Entrepreneurs Corner. okay, where you can make a lot of money. And we have this answer is for AK, okay, AK time, growth flow. You just go for the website called growthflow.ai. Let me check. There is a program for 1,400 rupees, okay, 400 rupees, where you can how to launch your course as like me, and how to earn in crores, okay, earn in crores, like learn and automate your course in 10 days, okay. Actually, this is a growth flow is a tool for business automation, okay, and this is a product of Pantech. It's our own tool, which is used for business automation, okay, online business automation and marketing automation. I don't want to talk much more about this tool, but please do explore this growthflow.ai, okay, which has a lot of list of features, and which acts as a 24/7 money making machine, okay. You can sell ebooks, you can sell your codes, you can make a lot of passive income. And I have a separate membership called Diamond membership, which will cost you 1 lakh rupee, where we guarantee for generating 50 lakh rupees in 1 year, okay, 50 lakh rupees INR in 1 year. And we have currently there are people who has enrolled from Malaysia, Australia, and from US, and one from Qatar, okay. So currently there are people who are attending this of called Diamond membership, okay. So where we guide you each and every step, like how to start a company, how to design the product, how to design a digital product, and how to market, how to sell, okay. So this is for it's AK time. It's AK time. It just if you are still interested, like if you want to take care, then ping me the chat available on the website. You will reach us, okay. My team will forward your email or phone number with me. Let's connect one-to-one and have a chat, okay. Okay, Kaushar Ali Ansari is asking about explain about the internship for 3WM. It's for single course, whereas this is for 4 course. Okay, that's a difference, and it has like okay. So Mayuk, what is slave and what is its significance? Mayuk Kumavat, like slave, like only the master can control and can decide to transmit or receive data. Slave just receives the data. Okay, slave cannot control other devices. Only master can control the devices. This is for Mayur. Okay. Can you help me to suggest some tips? Okay. Yes, Kaushar Ali Ansari, yes, DSO is built in this. You just check ADLM 2000, ADALM 2000. Okay, it's there. DSO is there. Signal oscilloscope is there. Okay. You also have the function generator. You also have the function generator. You also have the DSO function generator spectrum analyzer. You have. It's worth investing. It will cost you like 25,000 rupees, which when you come up for India, when it's landed, it has to be imported. There is no local suppliers. It has to be imported from US. Okay. Likito Sai, which process is best for IoT? You can use ESP32. That's best. Okay. For learning. For production, like it's different. So thank you so much for your time. Okay. Just type P for permission. If you have guide me how to build, just type P for permission for closing this session. Okay. See you on the next session tomorrow. We don't have class on Sunday. There is no class on Sunday. Only on Saturday, like we have classes. Just type P for permission. If you have any questions, put that on the chat box. You what I2C, everything. Augustine Joseph, I will explain the difference between UART, SPY, and I2C when we deal with UART session, which is on day 8 or day 9. I think so, day 8. Okay. So thank you, Hari Krishna. Thank you. And Alam, thank you. Praveen Kumar, thank you. Breakthrough Innovation, thank you. Kamya, thank you. MD Arman, thank you. Okay. Yashwan, thank you. Shatosh, thank you. So thank you so much for your time. See you on the next class tomorrow. Until then, bye-bye. Take care. Have a great weekend. Okay. Thank you so much. I'm signing off. Thank you.